Hello everyone, you are welcome to another video session of Python for All. In this video, we will talk about Python data structure. But before we go straight to Python data structure, let's look at Python indexing. Indexing is a way to access elements in a sequence such as list, tuple, or strings in Python. In Python, indexing starts at 0. So the first element in a sequence has an index of 0. The second element has an index of 1, and so on. To access an element in a sequence, you would use a square bracket with the index of that element you want to access. Note that the last element is accessed using -1, and the last but one element can also be accessed using -2. So you should know that in Python, the indexing starts from 0 as against other programming languages where the indexing starts from 1. So Python simply uses the natural counting method of 0 to 9. So having said this, let's go straight to data structure in Python. The data structure in Python include list, tuple, dictionary, set, and frozen set. We will start with the first one, which is the list. We'll look at examples and also discuss some methods of manipulating these different types of data structure in Python. Then, when we talk about each of these ones, we'll highlight where possible the application of each of these data structure in Python. Now, let's start with the list. A list is a data structure that can store a sequence of elements. Lists are mutable, meaning that they can be changed after they are created. Lists can be used to store a variety of data types, including numbers, strings, and objects. What that means is that we can store an heterogeneous data type using a list, as well as also we can store an homogeneous data type using a list. Lists have a number of methods that can be used to manipulate them. Some of the most common methods are append, where you add an element to the end of the list, as in the case of stacking; insert, where you insert an element into the list at a specific index; remove, that removes an element from a list; sort, sorts the list in ascending order; reverse, reverses the order of the elements in the list. These are just a few of those methods mentioned here. If you want to know all the method implemented in the list, because the list itself is a Python class, you can simply open your console. So I open this tab. I just want to show you how you can access all the method in the list class. So I will open my console. Once the console open, what you simply do is to go to this cell and call the help of list. Run this cell, and what you will see is this documentation string for the list class. There you see all the dunder methods implemented in the list. Of course, if you read from there, you see the class list object. The list is an iterable, and then it's a built-in mutable sequence, which I've said earlier. And then you can see all the dunder methods implemented here. You go down, you see they just go through them, go through all of these. Then after the size of, you can see append, clear, copy, count, element, index, insert, pop, remove, reverse, length, sort. These are all the class methods that can be used to manipulate the list. So having said that, let's go back to our subject matter. So these are many of those other ones. If you are in doubt, you just simply call help on list, and then you can see which of the method you want to use to manipulate the list. So let's take an example here. In this cell, I'll create a list of numbers 1 to 5, and then I print the numbers. Remember, the list begins with the square parenthesis and closes with the square parenthesis. If you run this cell, you see it prints the number 1 to 5. Now, I want to manipulate this list by appending another number to it. In this time, I want to append 6. So let's append 6 and also run this and see what the result gives to us. If I run this cell, it gives me 1 to 6. You can see that 6 has been appended to that list. Likewise, you can create an empty list and append to that empty list. So, in other words, you can have an empty list and you can build that empty list. So, in this case, I want to demonstrate that example with the variable known as books. So, I create an empty list of books and then I append the following books to it: Macbeth, Shakespeare, Sharks. If I run this cell and print books, you will see that I have Macbeth, Shakespeare, and Sharks as strings appended to the list. Now, I want to implement the method pop. Here, pop simply removes the last element from the list. So if I pop for the first time and I print, you see Sharks has been removed. If I rerun this cell again for the next time, I pop again, you see Shakespeare has been removed. If I pop a third time and print, it becomes an empty list. At this point, I have exhausted the elements in that list. If I pop again by running this over again, what do I have? It throws up an index error. Whenever you have a traceback error like this, what you should do is to quickly go to the last statement. You see, the last statement says here index error, pop from an empty list. What it means that you cannot pop from an empty list because we have already exhausted the elements in that list. We have removed 3 elements, we have added to the list. So there's no longer an element in the list. The list is therefore an empty list. So you cannot pop from an empty list. So having said this, let's move to the next data type, which is the tuple. A tuple is a data structure that can store a sequence of elements. Tuples are immutable. That means that they cannot be changed after they are created. Tuples are often used to store data that should not change, such as the coordinates of a point on a map. Tuples also have a number of methods that can be used to manipulate them, and the most common ones include count, index, and length. Lest I forget, you can also find the length of a list by calling length of that list, and it tells you the total number of elements in that list. Likewise, tuples. So let's take this first example here. I have a coordinates variable, okay, assigned to a tuple of 1, 2, and 3. If I run this cell and print coordinates, I have the tuple 1, 2, 3. You see here the tuple here begins with your parentheses. Now I want to try to append the number 2 to that coordinates variable that I've created, which is the tuple I've created. If I run this cell, you see it pops up an error. It says, look at the last statement there. It says attribute error. Tuple object has no append. It means the tuple itself is also a class, built-in class in Python, like the list. But in this case, there is no method append in the tuple class. So you cannot append to a tuple. Unlike in the list, you can append to a list. Also, if you want to find out the various method you have in the tuple, you simply go by to the console or open your Python IDLE or open your Tony IDLE. Just go to the shell and then call help, and then you enter tuple. If you run this cell, it gives you everything, all the method implemented in the tuple class. You will see it right there. It tells you what the class is all about. It tells you can see the tuple is a built-in immutable sequence, and it goes on and on to discuss the various Donda methods and also the class method implemented in the tuple. So let's go back to our subject matter. Now, let's look at major differences between lists and tuples in Python. So I have a simple table here. that talks about the features we want to compare the list and the tuple with. The first one is mutability. List is mutable, can be changed, can be altered. Tuples, no. Ordered, yes, both of them are ordered collection of data. The next we look at is, can they contain duplicates? Yes. So you can have duplicates of objects or elements in the list and also likewise in the tuple. Can they be used as dictionary keys? For list, yes. For tuples, no. No, because the tuple itself cannot be altered after it's been created. So those are just the differences between the list and the tuple. Now let's move to the next data type, which is the dictionary. Dictionaries are a key value data structure. We mentioned this earlier in our first set of videos, but here we'll dive more deep into what dictionaries are. So this means that each element in a dictionary is a pair of key and value. The key is used to access the value. So the key is a pointer to what value you have in that element of the dictionary. Dictionaries are a very efficient way to store data that is accessed by key. Let's take this example. Here we create a dictionary of contacts. The keys are the names of the contact and the values are the contact itself. You can see both of them are strings. So it means the dictionary itself can also take heterogeneous data. So if I print this by running this cell, I print contact, you see the dictionary is printed with the key and the value. The key and the value are separated by a colon. You can see that as shown in the printed result. Next, let's print the contact of Smith. So Smith is the key. In other words, I print contact and put in square parentheses the key, which is Smith. If I run this cell, it gives me the value, the contact of Smith, which is the value to that key. Also, I can decide to print all the keys in that dictionary. So I print contact.keys. It gives me a list of all the keys. So dic keys gives me all the keys. Likewise, I can print the contacts, the values in that contact dictionary. So I print contacts dot values with open and close parentheses. If I run that, it gives me all the values. Now, I can also access all the items in that dictionary. If I do that, I will have to print or call. You can either print or call, okay, which of them. If you are using the Jupyter notebook or the Jupyter Lab notebook, you just simply call, right? If you are running this on your IDE in the IPython console, what you do is just to print. You print the contact.items. So if I run this cell again, you see it gives me a list of tuples of keys and values. You have a list of tuple of keys and values because the key and the value are a pair. So they appear as a tuple, okay, in that list called dic items. Next, we'll look at sets. Sets are a unordered collection of unique items. This means that there are no elements in a set that can appear more than once. Sets are often used to store a collection of data that needs to be unique, such as the set of all possible values for a variable. We'll take an example. Here you see the set itself is denoted by a coil or brace bracket, but in this case it has no key value pair. So here we have a set of numbers 1 to 5. Now we can add to that set but not append. We can add to that set but not append. So the operation there is add. So I want to add a number 6 and print the numbers. If I run this cell, what I have is a set of 1 to 6. Okay. Now, if I decide also to add, let me run this cell again by adding another number of 5 and run this cell. You see, it prints 1 to 5, because you already have the number. Okay, before adding, let me print numbers first so that we see what we are trying to show here. I'll print numbers, then add 5 and print numbers. If I run this cell, you see before adding the element 5, I have 1 to 5. I have 1 to 5. You can see instead of having 5 repeated twice, it simply keeps only 5. That's what the set simply does. So there are various ways you can use sets. So if you want to store data structures where you don't want duplicates, simply use the set to do that. The last for today is the frozen set. A frozen set is a special type of set that is immutable. Once a frozen set is created, it cannot be changed. This means that you cannot add or remove elements from the set, and you cannot change the order of elements in that set. Frozen sets are created using the built-in function named frozen set function. Frozen sets are useful in situations where you need to create a set that cannot be changed. For example, you might want to use a frozen set to store the keys of a dictionary. Of course, you don't want the keys of that dictionary to change. So you can use a frozen set to store it. Now, if you look at between the set and the frozen set, you can see that sets are actually mutable, while frozen sets are immutable. In other words, you can add to a set, you can remove from a set, but in the case of frozen sets, you cannot do that. So since the keys of a dictionary cannot be changed, it makes sense to store them in a frozen set. Frozen sets are also hashable. I'll explain what hashability means. This means that they can be used as keys in dictionaries and as elements in other sets. Likewise, lists are also hashable. Okay, so having said this, let's look at a few examples of frozen sets. First, in this example, we have frozen sets being assigned called as frozen set 1, 2, 3. I have a frozen set of 1, 2, and 3. Now let's print the frozen set, and what do we have? You see it printing out the frozen set. Now let us try to create a frozen set of names, which are simply the keys of the contact dictionary we looked at earlier. So if I run this cell, I already have it created. Names. Let me print names to see what it contains. If I print names, you will see that the order has been distorted, but we have all the keys in the contact dictionary saved as frozen set, but it's not ordered, it is unordered. Okay. You can likewise access the names in that frozen set. Names is a frozen set. So I can access every element in names. How do I do that? I simply use a loop. So if I use a for loop, I can look through and then print out every element in names, which is a frozen set of the contact keys. Okay. So if I run this last cell, what do I have? It prints, I say for name in names, print name. So it prints the names Wayne Code, John Smith, Jane Doe. With this, we have come to the end of this video. If you have any question, please leave it in the comment section. Like this video, share this video, and if you have not subscribed to my channel, please do so. And do not forget to hit the notification bell to get notified of my new upload. Till then, see you in my next video. Bye.